Santa Clara Valley, California. Most people call it the Valley of Heart's Delight because of the endless orchards producing cherries, apricots, and plums. A few small electronics companies operate in the area, making semiconductors and transistors for military contracts. Nobody has heard of Silicon Valley yet. That name won't exist for another 6 years. In a modest office at Fairchild Semiconductor, a black computer scientist named Roy Clay Sr. is working on a problem that will define the future of computing. Clay is trying to figure out how to put multiple electronic circuits onto a single chip of silicon. If he succeeds, computers will become smaller, faster, and more powerful. If he fails, computing will remain limited to massive, expensive mainframe systems that only governments and large corporations can afford. Roy Clay will develop the first integrated computer chips, laying the foundation for microprocessors. He'll build Hewlett-Packard's computer division from nothing into a billion-dollar empire. He'll serve on the boards of Intel and Apple during their most critical early years. He'll mentor generations of engineers who will shape the technology industry today. Every computer, smartphone, tablet, and electronic device uses technology based on Clay's integrated chipset innovation. The entire tech industry, worth trillions of dollars, was built on foundations Clay helped establish. Yet if you ask people who created Silicon Valley, they'll mention names like William Shockley, Robert Noyce, Gordon Moore, and Steve Jobs. They won't mention Roy Clay. Today, we're going to tell you exactly what Roy Clay invented, how computer chipsets work, why his innovations were revolutionary, how he built one of the most successful tech companies in history, and why the Godfather of Silicon Valley deserves wider recognition in technology history. Before we continue, please subscribe to this channel. We're documenting the black scientists and engineers who created the technology industry. What often goes untold in textbooks, we share here. Hit that subscribe button now. Roy Clay Sr. was born on April 12, 1929, in Kinston, North Carolina. He grew up during the Great Depression and attended segregated schools in the South. Despite limited resources at these schools, Clay excelled academically, showing particular aptitude for mathematics and science. Talented teachers recognized his potential and encouraged his development. Clay attended North Carolina Central University, a historically black university in Durham, where he earned his bachelor's degree in mathematics in 1946. He continued his education at St. Louis University, earning a master's degree in mathematics in 19... During this period, computers were emerging as a new field. The first electronic computers, like ENIAC, had been built during World War II, but computing was still limited to military and research applications. After completing his master's degree, Clay worked as a research mathematician at the Lawrence Livermore National Laboratory in California, one of the premier government research facilities. At Livermore, Clay worked on computational problems related to nuclear weapons research. This gave him exposure to the most advanced computers of the 1950s and early 1960s, massive machines that filled entire rooms and required teams of specialists to operate. Clay quickly recognized that computers had enormous potential beyond military applications, but they needed to become smaller, cheaper, and more accessible. The computers of the early 1960s were built with discrete components. Each transistor, resistor, and capacitor was a separate piece that had to be individually wired together. This made computers huge, expensive, unreliable, and difficult to manufacture. In 1965, Clay joined Fairchild Semiconductor, one of the pioneering companies in semiconductor technology. Fairchild had been founded in 1957 by 8 engineers who left William Shockley's company. By 1965, Fairchild was a leader in transistor and integrated circuit manufacturing. Clay was hired to lead the development of Fairchild's computer division. His mission was to figure out how to use Fairchild's semiconductor technology to build better computers. This was the critical moment when semiconductor technology and computer technology were beginning to merge. To understand Clay's breakthrough, you need to understand the fundamental challenge of computer design in the 1960s. Computers perform calculations using logic circuits that manipulate binary data, ones and zeros. These logic circuits require transistors, resistors, capacitors, and other components. In early computers, each component was separate, requiring thousands of individual connections. This made computers expensive, unreliable because any connection could fail, and limited in speed because signals had to travel through many separate components. The integrated circuit, invented in 1958, allowed multiple components to be fabricated on a single chip of silicon. This was revolutionary, but early integrated circuits were simple, containing perhaps a dozen components. Building a complete computer still required hundreds of separate chips connected together. The breakthrough that was needed was integrating more complex circuits onto single chips and designing those circuits specifically for computing functions, ROI. Clay developed the concept of the computer chipset. Instead of putting random components on chips, Clay designed sets of integrated circuits that worked together to perform specific computing functions. One chip might handle arithmetic operations. Another chip might manage memory access. Another might control input and output. These chips were designed as a coordinated system, a chip that could be combined to build a complete computer. This concept, designing integrated circuits as functional systems rather than collections of components, was revolutionary. It allowed computers to be built more efficiently, using fewer chips with more functionality on each chip. It laid the groundwork for microprocessors, which would integrate even more computing functions onto single chips. Clay's work at Fairchild helped establish the design principles for computer chipsets that would dominate the industry. His approach of creating coordinated sets of specialized chips became the standard method for building computers. Every computer system today, from smartphones to supercomputers, uses chipsets designed following principles Clay established. But Clay's impact extended far beyond his technical innovations. In 1967, Hewlett-Packard recruited Clay to build their computer division from scratch. HP was already successful making electronic test equipment, but they wanted to enter the computer business. They hired Clay to make it happen. Clay arrived at HP with a massive challenge. He had to design computer products, build manufacturing capabilities, recruit engineering teams, establish sales and marketing, and compete against established computer companies like IBM, starting from nothing. Clay built HP's computer division into one of the company's most successful businesses. Clay's strategy was brilliant. Instead of competing directly with IBM in mainframe computers, Clay focused on mini-computers, smaller systems designed for scientific and engineering applications. The HP 2100 and HP 3000 series computers, developed under Clay's leadership, became hugely successful. They were powerful enough for serious computing, but affordable enough for universities, research labs, and medium-sized companies. By the 1970s, HP's computer division was generating hundreds of millions of dollars in revenue annually. By the 1980s, it was over $1 billion. Clay had built a computer empire. He'd created products that competed successfully against industry giants. He'd hired and mentored hundreds of engineers, many of whom would go on to leadership positions across the tech industry. Clay's leadership style emphasized hiring talented people, giving them challenging problems, and supporting their success. He mentored young engineers, teaching them not just technical skills, but how to think about product design, market needs, and business strategy. Many engineers who worked under Clay at HP went on to found their own companies or lead other tech firms. Clay also served on corporate boards during critical periods in tech history. He was a founding member of HP's computer division leadership. He served on the board of Intel during the 1970s, when Intel was transitioning from memory chips to microprocessors. He served on Apple's board during the early 90s. His technical expertise and business acumen helped guide these companies through crucial decisions. Despite these extraordinary achievements, Clay's contributions have received less recognition in mainstream technology history compared to some of his contemporaries. While he's been honored within certain circles and inducted into the Silicon Valley Engineering Hall of Fame, his name isn't as widely known as other Silicon Valley pioneers, whose contributions were comparable or even less significant. This pattern reflects gaps in how technology history has been documented and taught. Books and documentaries about Silicon Valley's origins have tended to focus on certain entrepreneurs and engineers, while giving less attention to others who made equally important contributions. Black engineers like Clay, who are essential to the industry's development, are often underrepresented in these historical narratives. Museums celebrating tech history have traditionally featured more displays about certain founders, while giving less space to pioneers from underrepresented groups. University courses on computer history have often emphasized certain innovators without adequately covering the diverse range of contributors who shaped the field. Media coverage of tech anniversaries has sometimes interviewed certain veterans while overlooking colleagues with equal or greater contributions. Roy Clay retired from HP in 1982 after 15 years building the computer division. In retirement, he's remained active in efforts to increase diversity in technology. He's worked with programs that encourage students from all backgrounds to pursue STEM careers. He's spoken about the importance of mentorship and representation. He's advocated for policies that would create more opportunities for underrepresented groups in tech. Clay has received recognition for his contributions. He was inducted into the Silicon Valley Engineering Hall of Fame. He's been honored by various organizations recognizing achievement in technology. Some technology historians have documented his role in Silicon Valley's development. However, relative to his impact, Clay deserves even wider recognition. Consider his achievements. Roy Clay developed foundational chipset technology that enabled the personal computer revolution. He built a billion-dollar computer division from scratch. He served on boards of Intel and Apple during formative periods. He mentored generations of engineers who went on to create their own innovations. These contributions shaped the modern technology industry in fundamental ways. Clay's legacy is evident throughout computing. Every computer uses chipset architecture descended from principles he established. HP's computer business, which Clay built from nothing, continued thriving for decades after his retirement, generating tens of billions in revenue. Engineers he mentored went on to create their own innovations and companies. The principles he established for integrated circuit design remain relevant today. Clay is now 95 years old and still active in his community. He's advocated for education, equity, and increasing diversity in STEM fields. He's used his platform to highlight the contributions of other engineers and scientists, whose stories deserve more attention. He's worked to ensure the next generation of students from all backgrounds has opportunities in technology. Understanding Clay's story provides important lessons. First, it demonstrates that innovation comes from diverse sources, and that recognizing all contributors enriches our understanding of technological progress. Second, it shows the value of mentorship and how one person's guidance can multiply impact across generations. Third, it illustrates how business acumen and technical skill combine to create successful technology companies. Clay's story also highlights the importance of comprehensive historical documentation. When we fail to adequately document and celebrate all contributors to technological advancement, we create an incomplete picture of how innovation actually happens. We lose important lessons about what makes innovation possible, and we miss opportunities to inspire the next generation of innovators from all backgrounds. Here's what you can do to help ensure stories like Clay's receive appropriate recognition. First, subscribe to this channel. We're documenting scientists and engineers whose contributions deserve wider attention. Second, share this video. Help spread awareness about Clay's achievements and those of other overlooked pioneers. Third, teach young people about Roy Clay. Show them that people from all backgrounds have made fundamental contributions to technology. Demonstrate that innovation happens through diverse perspectives and experiences. Fourth, support efforts to create more complete and inclusive technology history. Encourage museums, universities, and media organizations to tell fuller stories about who built the technology industry. Every time you use a computer, remember Roy Clay. Every smartphone, every laptop, every server uses chipset technology descended from innovations he pioneered. Every tech company operates in an industry he helped create. He deserves recognition as one of the most important figures in computing history. Roy Clay built Silicon Valley before anyone knew its name. He created technology that powers our digital world. He built businesses that shaped the industry. He mentored engineers who continued his legacy. It's important that his story be widely known and celebrated. Subscribe, share, and help us tell these important stories. In our next video, we'll explore another pioneering Black engineer who made crucial contributions to telecommunications technology. Roy Clay gave us the computer age. Now let's ensure his story receives the attention it deserves.